Okay, so this lesson we'd like to talk about the t-formula. So what is t-form? T-form is a formula that expresses that sine theta, cosine theta, and tangent theta. So basically express those into the algebraic function. All right, quite a useful strategy. We can just change the trigonometric function into an algebraic function. So sometimes it's just easier for us to solve an equation later on and prove trig identity using t-formula. Also, I'm not a fan of a t-formula, but it's a really important skills that you need to know how to do. All right, so we'll start with the formula straight away. If we let t equals to tangent half theta, now this is the key. We need to let t equals to tangent half theta. Then sine theta is equal to 2t over 1 plus t squared. Cosine theta is equal to 1 minus t squared over 1 plus t squared. And tangent theta is equal to 2t over 1 minus t squared. All right, so this is the, basically this is just a formula. So if t is equal to tangent half theta here, then we know sine theta is equal to 2t over 1 plus t squared. Cosine theta is 1 minus t squared over 1 plus t squared. And tangent theta is equal to 2t over 1 minus t squared. All right, so I'd like to show you and why this sine theta can be replaced by the t. All right, using the t equals to tangent half theta. All right, basically what we're going to use is the double angle formula. All right, so we'll start with the proof. And we're starting from sine theta first. All right, so the first step what we can do is we can change the sine theta into the double angle formula. So we change that theta into 2 times by theta over 2, like this. All right, and then if you use the double angle formula, that becomes 2 sine theta over 2 cosine theta over 2. All right, now previously we let t equals to tangent theta over 2. And from here we can draw a right angle triangle, and then we can use the SOHCAHTOA to write down the side distance. Okay, so if the angle here is equal to theta over 2, then that's equal to t, which means opposite over adjacent is t over 1. And if that's equal to t over 1, then the hypotenuse will be square root of 1 plus t squared. All right, it should be 1 squared plus t squared, but 1 squared is still equals to 1. So from here we can generate what's sine theta over 2, which is equal to the opposite over hypotenuse, and that is equal to t over square root of t 1 plus t squared. And then cosine theta over 2 is adjacent, which is 1 over hypotenuse 1 plus t squared. All right, so then the last one is tangent theta over 2, and previously we let t equals to tangent theta over 2, so that's just equal to t. So from these three results here, we can do a substitution to prove the previous formulas. All right, so let's just do a substitution here. We know sine theta over 2 is equal to that value there. All right, so that's sine theta over 2, which we can just now do a substitution. And then cosine, which is that part, this is the cosine theta over 2, we can replace that inside. So hopefully we can use the algebra to solve and prove the formula. All right, so that gives you 2 times by sine theta over 2, which is t over square root of 1 plus t squared, times by cosine theta over 2, which is 1 over square root of 1 plus t squared. That gives you 2t over, the denominator is you've got both square roots, so the square root cancelled out, now it becomes 1 plus t squared. So this is the first formula. Now we can do the same thing for the cosine theta and the tangent theta, again using the double angle formula. All right, so for cosine theta, we'll do the same thing. That gives you cosine 2 times by theta over 2. And we can use the double angle formula for cosine, which we just use the normal one, right, the square one. So cosine squared theta over 2 minus sine squared theta over 2. And then let's just do a substitution. So that gives you 1 over square root of 1 plus t squared, and a square, minus t over square root of 1 minus 1 plus t squared. and you square it. So that gives you a 1 over 1 plus t squared minus t squared over 1 plus t squared. All right, and that gives you 1 minus t squared over 1 plus t squared. That just gives you the formula there. All right, the last one is the tangent. You probably already know how to do the tangent one. Now, for the tangent, you don't really need to use the double angle formula because we know the tangent theta is equal to sine theta over cos theta. So we can use that identity to prove it. You can still use double angle formula if you want to, but all right, you don't have to. All right, we know what sine theta equals to. All right, in terms of t, sine theta is equal to 2t over 1 plus t squared. Over cosine theta is equal to 1 minus t squared over 1 plus t squared. Alright, so if you do the calculation by crossing this two denominator out, you are going to get the 2t over 1 minus t squared. So here we go. Those are the proofs for the t-formula substitution. Alright, so why do we need to learn the t-formula? Why do we need to express the trigonometry function into an algebra function? The main reason is just it's much easier to deal with algebra functions instead of trigonometry function later on, especially when you're solving equations. In year 12, you are going to learn how to solve harder trig equations using t-formula. So this is really important. For this exercise, all you need to do is be able to change the t-formulas, right? Be able to change the things around and be able to prove some trig identity questions. All right. Something that you need to be very careful about the t-formula is you can manipulate the t-formula quite, it's really flexible. I'll show you why. All right, so previously we let t equals to tangent theta over 2. And then we get the result, sine theta. We get the result of cosine theta and we get the result of tangent theta, right? And I'm just going to write one as an example. So, sine theta is equal to 2t over 1 plus t squared. Now, what happens if we let t equals to tangent just theta, not equals to theta over 2? Then in that case, we are going to generate this result. We are going to get sine 2 theta here. And that gives you 2t over 1 plus t squared. All right, same answer. So as you can see here, it's exactly the same expression. The only difference is if you want to write down sine 2 theta in terms of t formula, then you need to make sure that the t is always equal to tangent theta. So have a look at the relationship between these two theta here. That's theta, that's 2 theta. That's theta over 2, that's theta. So basically they are just doubling, all right, so they're double amount. So this is really important because in the future we might see questions where they don't give you sine theta or cos theta, they give you sine 2 theta, and they ask you to use the t formula to solve an equation, right? In that case, all you have to do is by just adjusting these t values, then you can write down the actual number there. So that should be quite easy, for you to do. All right, so let's move on to some questions here. So we're going to do some example question, and for this exercise, most of the example question will be just the trig identity question, and then I would like to do one with trig equation solving, using the t formula, so you can see why sometimes t formula is just a bit easier to do. Okay, so first one, prove 1 minus cosine theta over 1 plus cosine theta equals to tangent square half theta. All right, so here's the proof. All right, how do we prove it? Now, the first step is you start with the left-hand side. So you write down with the left-hand side. And then once you finish it, you do need to write down the let. All right, you need to write this one down. Very important. Let t equals to tangent theta over 2. This is extremely important, all right? If you don't write this statement, you can't change that sine or cos into t, okay? So you have to write down that statement. Once you write down a statement, all right, you can just use the formula. You don't need to prove it to use the formula. So it's just a formula for you to use, and you don't need to prove it. Okay, all right, so then what you do is simply algebra calculations, all right? So you want to get rid of the denominator, so I want to times both the numerator and the denominator by the denominator of the function, of the fraction inside, all right? So that becomes 1 plus t squared, All right, so you will get 1 plus t squared minus 1 plus t squared over 1 plus t squared plus 1 minus t squared. So that gives you, if you simplify this, all right, so 1 and 1 crosses out, t squared crosses out. So you get 2t squared, oops, different color, 2t squared over 2, which gives you t squared. Now, what is t squared? Well, we know it's t. T is equal to that expression here. So we can replace the t squared by tangent square theta over 2, which is exactly equals to the one we need to prove, which is on the right-hand side. So we just proved. So as you can see, sometimes trig identity equation can be very difficult to prove, but if you're using the t formula, as you can see, it just becomes slightly easier. All right? So that's the first example. All right, now I'd like to do the second example, but this time using a different t values. So example 2, prove 1 minus cosine 2x over sine 2x equals to tangent x. All right, using the t formula. Now, for this question here, if you don't use t-formula, you'll find this question a bit hard to prove. But you have to be very careful with this question. That's 2x. So, you have to use the method I used before. This time, you instead of letting t equals to theta over 2, or x over 2 in this case, you are going to let theta, or t, equals to tangent x. All right, very, very important because this is the double amount. It's not just x by itself. All right, so let's start. Left-hand side is equal to 1 minus cosine 2x over 1, sine 2x. Okay, we're going to let t equals to, very important, tangent x this time. All right, tangent x this time. So therefore, now we can just apply the formula. Cosine 2x, it just becomes the same expression that we have previously. All right. And then sine 2x is just be the same expression again, 2t over 1 plus t squared. All right, now do the same thing. Multiply both the top and the bottom by 1 plus t squared. All right, you're going to get 1 plus t squared minus 1 plus t squared over 2t. All right, if you cross these two out, you get 2t squared over 2t. And that gives you t. And what's t equals to? Well, t equals to tangent x. So that's just equal to tangent x, which is the answer we need to prove. Again, much, much easier than you simply use the double angle formula to prove that. Okay? Otherwise, you have to use the double angle formula to prove it, which sometimes the student finds it's a bit confusing to use double angle formula. Okay. All right. Now, let's move on to an equation solving. So, example 3. How do we solve an trig equation using t substitution? So here's the question. You're going to solve for a, all right? And a is between 0 and 2 pi. So how would you solve this? So how do we solve this one here? In year 12, you're going to learn something called auxiliary angle methods, but right now you can use the t formula substitution to solve it. So the first step you do is you're going to let t equals to tangent a over 2. All right, this time is still a over 2 because that number here is a, not 2a. All right, once you do that, then you can change that trigonometry function in our equation into the algebraic equation. So that becomes square root of 3 bracket 2t over 1 plus t squared plus, okay, and then for the cosine a, you get 1 minus t squared over 1 plus t squared is equal to 1 plus t squared. All right, so as you can see, you get that. All right, so keep going. So 2 square root of 3t plus 1 minus t squared is equal to, oops, made a mistake here. That should be just 1, is equal to 1 plus t squared here. Okay, so what I did here is just simply expand the bracket and also get rid of the denominator. All right, so now rearrange everything. So you got 2t squared minus 2 square root of 3t, and then is equal to 0. So that should be quite easy. All right. Hopefully I did everything correctly. So let's just double check. If you times this across, you get 2 square root of t. So denominator cancels out. And then, okay, good. So cross these two out. So you get these two expressions now. That's a quadratic function. All you have to do now is solve these quadratic equations. Take the 2t out. So 2t bracket t minus root 3 is equal to 0. So t is equal to 0, t is equal to square root of 3. All right. So once you finish that, we just finished finding the value of t. Now what we need to do is just solve for a. So then we can rewrite tangent a over 2 equals to 0 as the first answer, and then tangent a over 2 equals to square root of 3 as the second answer. All right, so we'll start to solve this equation, but what we need to do is to change the domain. All right, previously the domain is between a, but this time it's a over 2. So the domain is going to be a over 2, and it's between 0 and pi. So we're going to find all the values between 0 and pi. So let's just do that. So that becomes tangent, that becomes a over 2 is equal to tangent inverse 0, which gives you a over 2 is equal to 0 degrees, or 0 degrees, or 0 radian in this case, but we're dealing with radian. So the second answer is pi, because remember, all station to central. This is a tangent question, so the second answer will be pi plus the previous answer. All right, so a is 0 and 2 pi after you multiply by the 2. For the next one, all right, we'll do the same thing. A over 2 is tangent inverse root 3. Now this is a special answer. A root 3 will give you 60 degrees, which is pi on 3. Now we don't need to find the second answer, because if you plus pi on 3 by pi, you are going to get a number that's greater than pi, which that's what we don't want. So that gives you a equals to 2 pi over 3. So now you can see here we've got 3 answers. A equals to 0, a equals to 2 pi on 3, and a equals to 2 pi. And that's how you find the answer here. And this is called a t-formula substitution now to find or to solve trigonometric equations. There is another way you can solve this equation, but you are going to learn that later in year 12. So yeah, these are the steps, all right, for you to do it. So this is the type of question you are going to get, in exams by using the t-formula substitution. Please remember the formula, and please, use the method here to do the question. Okay, all right. Thank you. I hope you enjoyed the lesson.